Today we're going to talk about the chain rule. Let's say you want to find the derivative of x plus 3 to the ninth. Your first thought might be the power rule, but since there's a plus 3 here, we can't actually use it. If we really want to use the power rule, what we could do is expand this and differentiate term by term. Nobody wants to go and expand this, and there's an easier way to find this derivative. We're going to make a substitution into this function to make it easier to differentiate. I'm going to let y equal x plus 3 to the ninth. How could we make this simpler? What if we let one letter equal x plus 3? I'm going to make up a variable, say u, and I'm going to let u equal x plus 3. Using this now turns into y equals u to the ninth. That's good enough, but we don't actually know how to use this to find our derivative yet. Recall that the derivative of y with respect to x is just dy dx. You know that if we multiply this by 1, it won't actually change dy dx. We're going to multiply by 1 to help us solve our derivative. We just made up this u here, so let's try to make it useful. Since we have dy's and dx's, I'm going to multiply by du over du. And notice that we can rewrite this as dy du times du dx, or the derivative of y with respect to u times the derivative of u with respect to x. This is the derivative of y with respect to u. And we have that y equals u to the ninth, so we can use the power rule here to get dy du equals 9u to the eighth. Now if we want to take the derivative of u with respect to x, we can just use the power rule again to get that this is 1. The problem asks for dy dx, so now we just have to multiply these together, like so. And now after we're done using u, we have to get rid of it because we can't express an answer in terms of things we made up. We said earlier that u is equal to x plus 3, so we just have to substitute an x plus 3 into here, and this is our final answer. The premise behind the chain rule is that we're taking a difficult problem, we're making it easier by making a substitution and then plugging back in. In general, if you're trying to find the derivative of a function with a function inside it, it's just the outer function times the inner function. The mnemonic you can remember this by is d outer d inner. So for example, if you have sine of 3x squared, the outer function is just sine and the inner is 3x squared. Remember, you always take the derivative of the outer with respect to u, not x. And you should also know you can use the chain rule more than once, like in this problem. So I have y equal to e to the sine of x squared, but we only know how to take the derivative of e to the x or e to the u, just e to one entity. I'm going to let u equal sine of x squared, so this becomes e to the u. Remember, for the chain rule, our derivative is the outer times the inner. dy du is the derivative of e to the u with respect to u, which is just e to the u. And the derivative of u with respect to x is the derivative of sine of x squared. But wait, we can't actually take the derivative of sine of x squared because we only know how to take the derivative of sine of x or sine of u or sine of one entity. So I'm going to let v equal to x squared. So this becomes sine of v. And the way we incorporate v into this is we're going to multiply this by dv over dv. Here I've multiplied by 1, so I still haven't changed the derivative. And then I'm going to rearrange the denominators here like this so we can actually use dv. So now if you want to take the derivative of du dv, this is just cosine of v. Finally, if you want to take the derivative dv dx, this is just 2x due to the power rule. Our answer is 2x e to the u times cosine of v. But remember, we can't have u or v in our final answer because we made those up to make our problem easier. We have to substitute back for u and substitute back for v, and this is our final answer. For our last example, we're going to take the derivative of ln of cosine of x. So I have y equal to ln of cosine of x. We only know how to take the derivative of ln of one entity. So I'm going to let u equal cosine of x so that y equals ln of u. Remember that our derivative is equal to the outer function times the inner function. The derivative of the outer function is 1 over u. The derivative of our inner function is negative sine, like so. But remember, we can't have u in our answer because we made it up, so we have to substitute back. Now I substitute it back for u, and look at that. This simplifies to negative tangent of x. And that's our final answer. And that's how you use the chain rule.